Hey guys, welcome back to my channel. So today I'm going to explain to you about chapter 4, acid and base. So first and foremost, I would like to thank all of you that have dropped some questions in the Padlet. So I'm going to go through this question one by one. I've already merged all the questions together because some of you did ask an almost similar question between one another. So I have managed to compile this, and it turns out we have 10 major questions that I will discuss it now. So I'm going to start with the simplest question. What is the difference between acid and base? So generally, if it's an acid, the pH should be lower than 7, and if it's a base, it will have pH higher than 7. So another thing is that the attributes of an acid is that it will have the sour taste, and for base it will have this like soapy feelings when you touch it. Alright, so another thing that we can do to discuss about acid and base is how do you define acid and base? So most of you ask what is the difference between these two definitions, which is the Bronsted-Lowry acid and base theory, and also the Lewis acid and the Lewis base. So I'm going to explain now about the Bronsted-Lowry theory. So in Bronsted-Lowry theory, it states that for an acid, it should donate a proton, which is a H+, and for base, it will accept the donated H+ inside it. Alright, so how are we going to explain more? I'm going to show you in this video. So for example, in this question, so if you can see the first one, HC2H3O2, right? So this one, and then it will react with the HO2. And let's look at the product. You will have the H3O+, and you will miss one hydrogen from here. It means that what we do is we are going to donate one hydrogen over here to the H2O. So since this substance is donating the hydrogen or the H+, so we consider this as an acid. Okay, so this one shall be the base because it accepts this H+. Right, so now we are going to look at the same reaction but from the other side. So we are going to look from the product to the reactant. So if you look at the product, you will have the H3O+, the hydroxonium, right? So from the H3O+, it will turn into H2O, and from the C2H3O2, it will turn into HC2H3O2, means that it will add one more H around here. So it means that the H+ is donated by the hydroxonium over here. So it means that it donates. So since this is donating the H+, it means that this one is the acid and this one shall be the base. Okay, so if you merge this thing together, means that this is the base and this is the acid. Okay, so this is where we will get the acid base conjugated, the conjugated acid base. So this one and this one is the conjugated acid base, and this one is the conjugated acid base, whereby at first this is an acid, it became base, and this one from base it will turn into an acid. Alright, moving on to the definition of acid and base, Lewis acid and Lewis base. So as opposed to the Bronsted-Lowry theory, where acid is denoted by the substance that donate the proton, but in Lewis acid, it is an electron pair acceptors, and the base is electron pair donors. So I'm going to explain more about this in the following slide. Okay, let's explain about the Lewis acid and Lewis base. So from the definition, a Lewis acid is an electron pair acceptor, while the Lewis base is the electron pair donor. So I'm going to give you 3 examples around here so that you can understand more about which one is the Lewis acid and which one is the Lewis base. So for example, the first question, you have BF3 and the NH3, and this will be the product. Okay, so if you look at this one, there will be no lone pair or lone electron inside this substance. But if you look at the NH3, in the end it will have one lone pair. So it have 2 electrons that is not bonded to other things, right? So it means that since the presence of this lone pair, so this lone pair will go there. So it means that this particular NH3 will be denoted as the Lewis base. So since that this is the Lewis base, definitely will be Lewis acid. Right, I'm not going to explain how it will attack this part. I'm just going to define which one is the Lewis base and which one is the Lewis acid. So in terms of the second question, okay, how are you going to do this is that you look at this thing. For chlorine, it have no electron that is not bonded to anything. So but Cl, just a Cl negative, right? So remember, Cl is at the halogens, right? Means that it have 7 valence electron. So since it have minus here, it means that it already received 1 electron. So it means here it should have 1, 2, 3, 4, 5, 6, 7, 8. So it have 8 valence electron that is not bonded to other things. So this have altogether 1, 2, 3, 4 lone pair. So one of these lone pair will attack your sperm, and this will create this one, making this whole molecule to be -1 charge. Alright, same like the third question, when you react this with water. Remember, in water you will have 2 lone pair, right, for the oxygen. Alright, so this lone pair will always attack the zinc. So it will connect here. So you will have another lone pair around here, still lingering around here. So here, because it have lone pair around here, so we consider this one is the Lewis base, and water here is the Lewis base as well. Another great question from you is that you ask how do our body regulate the pH? So the main thing that regulate our pH in our body is actually the respiratory system and also our kidney. So do you know that in our respiratory system, when we inhale and exhale, we actually, during the exhalation, we remove the carbon dioxide. And this is very important for us because this will ensure that the pH in our body will be regulated, because the carbon dioxide is a little bit acidic. So when you exhale, you are removing that carbon dioxide out, so you are going to in such a way regulate your pH in the body. And then another thing is that your kidney do helps in regulating the body pH. So for example, this kidney will regulate the amount of lactic acid that contained inside your body. So the kidney will remove the excessive amount of lactic acid inside your body. Therefore, it will maintain your pH in the body at the pH that it's supposed to be. Another excellent question from you all is that you asked me to define or to explain how do you know that if the acid is a strong acid or a weak acid. Okay, that's a good question. So in your test or in your final exam, what you can look into is if the question provides you with the value of Ka, or you were asked to calculate the value of Ka for that particular substance, it's a hint that that might be a weak acid. And then another thing, for you to know whether it's an acid or a base, an acid should always have hydrogen inside of their chemical molecular formula, and usually the H will be at the front. And then you can know that it is a strong acid by looking at the value of the pKa. So remember, it's different between Ka and pKa. So when you want to know whether it's a strong acid, it should have the value of pKa lower than -1. And then you can always remember for acid like HCl, HBr, HI, and like H2SO4 and perchloric acid, these are examples of strong acid as opposed to the weak acid. And then why? You need to know why. What is the difference between the strong acid and the weak acid? For the strong acid, it will dissociate completely. And for weak acid, it will not dissociate completely. It means that it will be partially dissociated. That is why the ice diagram plays an important role.